In this video, we shall look at how to calculate the determinant of a 4x4 matrix. Assume we have the following determinant. Step number 1, as with the determinant of a 3x3 matrix, is to determine all the cofactors. So we are going to choose the top row to determine all the necessary cofactors. So let's do just that. So we will start with the first element in the first row, namely 2. So the cofactor of that element 2 consists of this determinant of order 3, which is 1, 3, minus 2, minus 2, 1, 1, 1, 2, minus 1, multiply with minus 1 to the power of the row of element 2 plus the column of element 2, which is 1 plus 1. So in this case, this term will simply become 1. Now we have to multiply this cofactor by the element itself, which in this case is 2. Now let's move on to the second element in the row, which is 1. So by crossing out this 1 in two mutually perpendicular directions, noting that we are dealing with element 1 there, let's calculate the cofactor. The cofactor is minus 1. This is row 1, column 2. 1 plus 2 is 3, times the remaining order 3 determinant, which is minus 2, 3 minus 2, 1, 1, 1, minus 3, 2, minus 1. This entire term is simply minus 1. Now the third term in the row, which is minus 1, so it simply becomes minus 1. Now the cofactor, minus 1, this is row 1 and column 3, so 1 plus 3 is 4, times the order 3 determinant, minus 2, 1, minus 2, 1 minus 2, 1, and finally minus 3, 1 minus 1. So this entire thing is minus 1. And the final term is the last element of the first row, which is 1. So that is plus 1. The cofactor is, this is row 1 in column 4, so 1 plus 4 is 5. The remaining order 3 determinant is minus 2, 1, 3, 1, minus 2, 1, minus 3, 1, 2. That is those terms. And this entire term is minus 1. So there we have it. We have 4 order 3 determinants that we need to calculate. So let's first calculate term A. We can use the first row again to determine this order 3 determinant. So let's do just that. Multiply the overall factor 2 with the remainder of the expansion. So the first term in the expansion, so you have element 1 times the cofactor. So this is row 1, column 1. So 1 plus 1 is 2. And you have this 2 by 2 matrix determinant, so which is 1, 1, 2 minus 1. Now let's move on to the second term in the row. So that is 3. So the cofactor is minus 1 to the power 1 plus 2. So that is 3. The remaining order 2 determinant is minus 2, 1, 1, minus 1. The last term in the expansion, so you have the term minus 2. The cofactor is row 1, column 3. So 1 plus 3 is 4. The remaining order 2 determinant is minus 2, 1, 1, 2. So that is these terms. So this becomes 1. This determinant is minus 1, minus 2. So that's minus 3. The second term, that's minus 3. 2, minus 1. So that is 1. The third term is minus 2. The minus 4, minus 1. So minus 5. So minus 3, minus 3, so that's minus 6, plus 10, that is 4 times 2, you get 8. So the value for A is 8. Now let's do the term B. We can use the second row to determine this determinant. So the first element in that row is 1. The cofactor is minus 1, so this is row 2 and column 1. So 1 plus 2 is 3. The remaining determinant is 3 minus 2, 2 minus 1. Now let's move on to the second element. Again, it is 1, so plus 1. The cofactor is minus 1. This is column 2. Row 2, 2 plus 2, that is 4. And the order 2 determinant is minus 2 minus 2. This is minus 3 minus 1. And finally, the last term in the row number 2. The element itself is 1, so plus 1. The cofactor, this is column 3 and row 2. So 2 plus 3, that is 5. And the 2 by 2 matrix determinant is minus 2, 3, minus 3, 2. So this is minus 1. This is minus 3 minus minus 4. That's going to give you 1. This one here is 1. This is 2 minus 6. So minus 4. This term here will give you minus 1. This is minus 4 minus minus 9, which is 5. So B is quite simply minus 1 plus minus 4 plus minus 5. Let's not forget the minus that already exists in front of that term B. So factoring that minus in, you get 10. So B is 10. The next term in the expansion is C. So we can deal with the first row. So let's write down the overall minus and take it from there. So the first term is minus 2. The cofactor is, this is row 1, column 1, so 1 plus 1 is 2. The leftover determinant is minus 2, 1, 1, minus 1. Element number 2, which is 1. The cofactor, this is again row 1, column 2. 1 plus 2 is 3. The leftover determinant is 1, 1, minus 3, minus 1. 1, 1, minus 3, minus 1. And the third element in that row is minus 2. The cofactor is minus 1, so row 1, column 3, 1 plus 1, 1 plus 3, that is, which is 4. The leftover determinant is 1, minus 2, minus 3, 1. So that is that. This is minus 2, this is 1. This is minus 1, this is 2, this is minus 2, and this is minus 5. So minus 2 plus minus 2, which is minus 4, plus 10, which is 6, times minus 1, you get minus 6. So C is minus 6. C is minus 6. Now one last term is the term D. So let's do this. The overall minus 1. We can deal with row 1. So the first element is minus 2. The cofactor is minus 1 to the power 1 plus 1. So that is 2. The remaining determinant minus 2, 1, 1, 2. The second element is element 1. So plus 1. Cofactor is minus 1 to the power 1 plus 2. So that is 3. The remaining determinant is 1, 1, minus 3, 2. And the last element, which is 3. So plus 3. Cofactor is, this is row 1, column 3. 1 plus 3 is 4. Remaining element is 1 minus 2, minus 3, 1. So this is minus 2. This is minus 5. This is minus 1. This is 5. That is 3. And again, this is minus 5. Overall, 10 minus 5 is 5. 5 minus 15. Minus 10 times minus 1, you get 10. So D is 10. So the final answer is 8 plus 10 plus minus 6 plus 10 is 22. That is the answer to this determinant. Now let's look at this determinant. It is also determinant of a 4x4 matrix. Note the unique structure of it. These are the elements. This corner, the elements are all 0, and here it's -1, 0, 0, -1. So let's expand this in terms of bunch of order 3 determinants. We can use row 1. So let's start expanding. So the first term, that is the term A, the cofactor is 1 plus 1, 2, and the remaining determinant is 0, D0, 0, 0, EF, -1, GH. Now the second term, namely B. So that's going to give you B. The cofactor is -1. This is row 1, column 2. So 1 plus 2 is 3. The remaining determinant is C0, 0, -1 EF, 0 GH. You don't have to consider the other two because they will just give you 0. So that is 1. This is -1. So what do you have? A times that determinant, and in this case it's just minus B times that determinant. Now let's look at the first determinant and use the first row. So only D is non-zero, so that's going to give you D. The cofactor is -1, 1 plus 1, so that is 2. And E times H is EH minus GF. Everything else is 0 because these two elements are 0. Do not forget A, so write down A there. Let's look at the second determinant. We can use the first row. So that's going to be C -1, 1 plus 1 is 2. E times H is EH minus GF. And let's not forget this minus B. So this term and that term will simply give you AD minus BC times EH minus GF. Note, they are the same terms. What that means is the first term is quite simply an expansion of a order 2 determinant, namely A, B, C, D. And the second term is an expansion of the other order 2 determinant, EF, GH. So the point is, if you are given a determinant of a 4x4 matrix and you inspect its form and it has this form, then namely what you have to do is simply take the two order 2 determinants and multiply them to get the overall answer. So here is such an example. You have the same structure as before, so that is the 2x2 matrix determinant. So the answer is quite simply the product of two determinants, one of which is 1, 3, minus 2, 5, and the other one is that determinant, 4 minus 2, 6 minus 5. So the first one, 5 minus 6, which is 11. The second one is minus 20 minus 12, which is minus 8. So immediately you see the answer is minus 88. Another special matrix is this so-called triangular matrix. Note the elements below the diagonal elements are all 0. So let's use this column to evaluate it. W minus 1, 1 plus 1, X, E, F, O, Y, G, O, O, Z. So this is just W. Let's evaluate the order 3 determinant using that. So row number 3. Only Z, everything else is 0. Cofactor is, this is 3, and this is 3. So minus 1, 6. Remainder is X, E, O, Y, which simply give you W, Z, X, Y. So the value of the determinant is simply the product of the diagonal elements. So for such a numerical matrix, we can simply get the value of the determinant by multiplying all the diagonal elements. And the answer is 2 times 3 times 1 times 7, which is 42. If you have enjoyed the video, please consider hitting the like and subscribe button. Thank you for watching.